Welcome back, Physics 30. This is the Unit 1E Part 1 booklet dealing with acceleration. So it pertains to pages 81 to 87 of your booklet, and the things we'll be looking at here are, first of all, defining acceleration, looking at the SI units for acceleration, distinguishing between positive and negative acceleration, and then finally calculating acceleration. So acceleration, first of all, is by how much velocity is changing. So the rate of change of velocity could be changing, increasing or decreasing, or of course zero. Now, since velocity is a vector which has a magnitude and direction, acceleration does as well. So to change speed or change direction would be an acceleration. So three ways in which a velocity can change. The speed can change, but direction stays the same. Or if the speed doesn't change, but there's a change in direction, for example, going 20 kilometers per hour in a circle, that's an example of no change in speed, but direction is changing. And then finally, changing speed and direction. Okay, so there you have it, the three ways in which a velocity can change, which is also ways in which acceleration can change as well. So of course, if you are in a vehicle, you can always determine if acceleration is occurring because your body is moving. It's not staying stationary in the car. It could be pressing back against your seat or moving forward, etc. Acceleration is calculated as a change in velocity over a change in time. So for a change in velocity to happen, we could have v2 minus v1, and of course change in time, t2 minus t1. So a couple of fill in the blanks here. Acceleration is a vector quantity, and since it's change in velocity, meters per second, over change in time, seconds, this is what the unit looks like here, meters per second per second. And of course, really on the bottom here in the denominator, it's seconds over 1. If you invert and multiply, another way of expressing it is meters per second squared, which means the same thing as meters per second. So it's kind of an interesting unit there. When velocity increases in a certain direction, whether it's positive direction or negative direction, remember that negative doesn't necessarily mean slowing down, it's just the direction you're going. So if you're increasing velocity in the direction you're going, acceleration is said to be positive. If velocity is decreasing in the direction you're going, it's negative, or the opposite sign. And when velocity is constant, that means velocity is not changing, therefore you are not accelerating. You're not speeding up or slowing down, you're going at a constant speed, so acceleration is zero. And of course, zero velocity means if you're not moving at all, of course you're not accelerating there as well. Okay, so here's we'll end this off with a few problems, then a vocab. Cyclist accelerates from 5 meters per second south to 15 meters per second south in 4 seconds. So you can see that the speed is increasing here. The direction is staying the same. What is the acceleration? So we can think of it as v1 is 5 meters per second, v2 is 15 meters per second, time is 4. So easily enough here, v2 minus v1 over the change in time that occurred. So 15 minus 5 over 4, we get 2.5 meters per second south, or meters per second squared south. I'm also going to point this out, which is what you would have seen in Science 10, a way of manipulating a formula. A is equal to V over T. So if we're looking for T, V divided by A, as seen up here. Or if we're looking for change in V, A and T are side by side, multiply. Okay, so you may want to copy out these rearrangements here if you kind of have difficulty manipulating equations. A jet plane accelerates from rest. Now, whenever you see the word rest, that means zero. You're not moving. To 750 kilometers per hour in 2.2 minutes. What is its average acceleration? And I'm suggesting here just leave it in units of kilometers per hour per minute. So over time. So you don't have to have seconds and seconds. You can have it like this. For very fast objects such as a plane, sometimes we leave the speed in terms of kilometers per hour. and the time in minutes or seconds if it's even a faster object. So V1 is 0, V2 is 750 kilometers per hour, time is 2.2 minutes. So again, looking for acceleration, same equation, V2 minus V1 over t. And when you do that, you should get 350 kilometers per hour per minute, and it's in the positive direction, since we weren't told anything else. Next, a runner accelerates from, now be very careful with the wording on this one, accelerating from this to this. So these are still velocities here. They're still speeds, and I turned them into velocities by putting the directions in front. Don't get confused that they're accelerations. It just simply says it accelerates because we're going from this velocity to this velocity. What is the acceleration? Same as the previous questions. We know V1, we know V2, we're looking for t. So when you figure that out, you should get that. Okay, maybe you want to try the next view, so maybe pause the video, see if you can set these up, and then figure out the acceleration or velocity or time, whichever is being asked for. Okay, if you had time to do those, driver on the outskirts of the city slows down from 90 kilometers per hour to 50 kilometers per hour in 10 seconds. So you can see you're slowing down there. Find the car's average acceleration. You can leave your answer in units of kilometers per hour per second. So this is a case in which we're going faster, we're slowing down. So our A is going to be negative here. It's going to be the opposite direction. Or if we're going in the positive direction, acceleration is going to be acting negatively on us. So V2 minus V1, 50 minus 90, yes, you put the smaller number first, it's okay, over 10, and we get negative 4.0 kilometers per hour per second. And the negative there is implying, in layman's terms, decelerating or slowing down. Okay, a ball rolls up a hill, giving it a velocity of 4.5 meters per second north. 5 seconds later, the ball's rolling down the hill, 15 or 1.5 meters per second south, which the ball's acceleration. So you can think of it as something like this, a scenario like that. Now, instead of using north-south, we may wish to use positive and negative. So I assign north as a positive, south as a negative. So it's going to be negative 1.5 minus a positive 4.5 divided by 5. When you figure that out, you get something like this. And I kind of rounded a room here, so I kind of went down here. So negative 1.5 minus 4.5, that's going to give you a total of negative 6. So we get negative 1.2 meters per second squared. And of course, we earlier assigned negative as being south, so I changed this negative into south. I could have left it like this, but since the original question talks about north-south, I turned it back to south. Okay, lastly, definition for acceleration, and I think that's it for this booklet. So acceleration, rate of change of an object's velocity. So of course, A is equal to change in V over change in T, and to figure out that change, it could be V2 minus V1 over T2 minus T1. So there you have it, the first booklet, acceleration. See you shortly.